Today we'll be teaching you about chapter 6.1 Euler's method and how to use it. Euler's method is a way to approximate a point on a graph. As you can see here, for this graph you start at an initial point, in this case x naught, y naught. And from here you would add increments of h to x. These will be equal increments each time you add your next point. For the change in y is going to be increasing in this case as you change each point. To calculate your next value of y, you add your prior value of y plus your change in x times the slope at that point. This will give you delta y because your slope equals change in y over change in x. So multiplying it by your change in x will give you your change in y. And as you can see, these segments of line closely follow the graph. Not exactly, but you can use this to approximate a certain point on the graph. As an example problem, we have, using Euler's method, construct a table with approximate values using n equals 3, so we'll be using 3 different points and calculating the third. And the equation y prime equals x minus y, starting off with the initial value 0, 4. So to begin with your chart, we have n, our x values, and our y values. So as we have here, we have when n equals 0, when n equals 1, 2, and 3. So starting off with our initial, we have 0 and 4. Now, to calculate what our x values are, we add our increments of h, which is in this case h equals 0.05, which will be given. So for when n equals 1, we have x adding 5.05. For our next value, 2, we have 0.1. For our next value, when n equals 3, we have 0.15. Now, to calculate our y values, we must use our prior equation, which is yn plus 1 equals yn plus h times the slope at our starting point. So in this case, for when n equals 1, we have our prior value, which is 4, plus 0.05, because that's our change in x, times the slope at that point. So in this case, it will be 0 minus 4, which equals 3.8. So we put that there. Next, for when n equals 2, we have y of 2 equals 3.8 plus 0.05, which is our change in x, then 0.05 minus 3.8, which will give us 3.6125, about. So we put that there. For our final point, we repeat the process yet again. For when y equals 3, we have 3.6125 plus 0.05, and our slope, which would be 0.1 minus 3.6125, which will equal about 3.43 3.437. So in conclusion, for our third value of n, our final approximation of that point will be 1.5, 3.437. And that is our answer to using Euler's method to construct the third value of n.